rushed through the questions last week. Okay, so just have a little bit revise on what we have learned last lesson. Last lesson we have go through like how to sketch a circle. So we have two type of form for a full circle. So the first one is in the center radius form. We have x minus h squared plus y minus k squared give you r squared. So we can have circle like this. For a circle, there's many points you need to label. There's xy intercepts or xy intercept. We have center and we have the 4 points like at the very far, like far horizontal and vertical from the center. So that's all the points we need to label. Also, we have a general form, like an expanding form for a circle. So if you have the same number of x and same number of y, then that same number of x squared, same number of y squared, then that's a circle equation. So if we want to see what it looks like, we need to put it back into the center radius form by completing square. So after we complete the square, we have x plus 3 squared plus y minus 2 squared equals to 11. So we know the radius will be 11 and center will be minus 3 over 2. That's how we sketch for it. And then we have another two type of semicircles. We have the top and bottom semicircle, and we also have the left hand side and right hand side semicircle. If y is the subject, that must be the top and bottom. Then we look at the positive or negative in front of the square root to decide whether it's a top or bottom. Also, like to distinguish between a semicircle and the square root function is we look at the inside function, whether it's a linear or a quadratic. If it's a quadratic, that must be a semicircle. If it's a linear, then that's a square root. Also, for sketching it, I would like to put it back into the center radius full circle form, and then I can just decide where's the center, what is the radius, and then make and draw the appropriate part. So just quickly go through this one. This one we know that's x to be the subject. We know it's left hand side or right hand side semicircle. And also we have a minus sign here. That means it's a left hand side semicircle. Then I want to put it back into the form. So I will put x plus 2 equals to minus square root 49 minus y minus 2 squared. And then I can square both sides to get rid of the square root. Then we have x plus 2 squared equals to 49 minus y minus 2 squared. And that is x plus 2 squared plus y minus 2 squared equals to 49, which that's 7 squared. We know the center is minus 2 and 2. And we know the radius equals to 7. Okay, that's how we're going to sketch for it. You should finish sketching this already, so just check your answers here. We have center at negative 2 and 2. And then we have radius 7. This is the circle, negative 2, 2, negative 2, well, it's 7, so we have 9. And here we have negative 2, we minus 7, which is minus 5. And then plus 7 on that side is 5, 2. And then minus 9, 2. Yeah, that's a semicircle, sorry. So we only need the left hand side. Okay, we only need the left hand side. So we only have this a red color. We only need this part of the graph, so we don't have here. It's only from like closed circle for both ends, -2, 9, -2, -5. That's the semicircle here. Also, we can see there's no y-intercept because we don't have the right-hand side, but we have one x-intercept. And you can see the x-intercept is the smaller x-intercept. Okay, so the larger one is on the side. So what we can do is make when y equals to 0. And we solve for x. Oh, I can directly sub into the original equation. Can I see sub into the original equation instead of sub into the like later one, the full circle one. So I'll sub y equals to 0 into the function. I already have x to be the subject. That's why I want to sub in that one. So x equals to -2 minus square root 49 minus when y is 0, that's -2. -2 squared will be 4. So x equals to this. And that's 45. -2 minus 3 root 5. -2 minus 3 root 5, comma 0 here. That's the x-intercept. And I don't need this point. And I can see my domain will be -9 to -2 inclusive, and the range will be -5 to 9 inclusive as well. Okay, so just a little bit revise on semicircle. And you should know one thing, okay? So from the center to any point on the circle, the distance will give you the radius. Okay, so from the center, connect any line, like straight lines, to the edge of the circle. You can have your radius. You can use the distance formula to find the radius. Okay, square root y2 minus y1 squared plus x2 minus x1 squared. Because we're going to do one question here. I've asked you to do example 1 and 2 already, but let's have a look at example 1 and 3 already, but let's have a look at example 2 first. Okay, let's have a look at example 2 first. Example 2 says, find the equation of the circle whose center is at the point 1 and -1, and which passes through the point 4, 3. Okay, you have a circle. You know the center already. So you can use the center radius form. Okay, you can use the center radius form. So you will have x minus 1 squared plus y plus 1 squared equals to r squared. So when you know the center, that's the first thing you can write for a circle. Because you know the center, you know the h value and k value. My question here is, how you can find out r? Yes? Sub the point 43 to solve for r. Okay, that's right. That's one method. Is there any other method we can do? Distance between those 2 points. We can solve out radius as well. Okay, both methods will work. If we do the substitution one, we can have a look. If we sub x equals to 4 and y equals to 3. Okay, so 4 minus 1 squared plus y plus 1 squared equals to r squared. I can easily solve out r squared as well. So that's a 9 plus a 16 equals to r squared, and r squared equals to 25. Okay, 25. So the formula will be 5 squared. Or if you think about, okay, we just need the r value. We want to know what's the radius. So we have the center. We have a point on the circle. If we find the distance between them, that will give me the radius as well. So I can use square root 4 minus 1 squared plus 3 minus negative 1 squared. Well, the test I just returned back, I find someone who can't do distance formula, like just, or like know how to use it, but like sub the wrong way, like use, I think give a wrong formula when I mark it. So just be careful. That's a really well used formula. So please remember that. Okay, you keep using it until you graduate, or maybe even in the uni. So you will keep using this formula here. So the distance formula, the midpoint formula, and the gradient one. So you keep using that over the whole year. So y2 minus y1, x2 minus x1 squared. We have 9 plus 4 squared, which is a 16, and then square root. And that will be 5. So radius will be 5 here as well. Okay, so that's example 2. Come back to example 1. So last, I think previous 2 lessons I asked you to do example 1 and 3. So you have a rectangular hyperbola which with that equation. Okay, the equation is already given to you, and this passes through the point 2, 7, and negative 1, 1. Find the value of a and k. This just is an easy substitution question. So 7 equals to a over 2 plus k, and 1 equals to a over negative 1 plus k. Okay, so for the second equation can become, that's a minus a, so 1 plus a will equals to k. Okay, plus the a to that side, 1 plus a equals to k. So I can sub that into the first equation here. 7 equals to a half a plus 1. So that's the k. Okay, plus a plus 1. So 6 equals to 3 over 2a, half a plus 1a, that's 3 over 2a. And a equals to 6 times, well, you can say 6 divided by 3 over 2, and that's 6 times 2 over 3. And a gives you 4. Then k will give you 5. And you need to better like check it. Okay, you sub the point 2 in. So that gives you 2. 2 plus 5 equals to 7. And then you sub negative 1 in. Negative 4 plus 5, that gives you 1. So, which means you solve it right. Okay, that's example 1. And have a look at example 3. Find the value of a, h, and k. Okay, this is a truncus. Okay, this is a truncus. So we have the vertical asymptotes and the horizontal asymptotes. That must be x minus 2 squared and plus a minus 3. Okay, because the k value is negative 3. So give you the horizontal asymptotes, and the vertical one is x equals to 2. So it must be x minus 2. Okay, so x minus 2. And then we need another point to solve for a, and the point is given. And the point is given as the y-intercept, which is 0, negative 11 over 4. So we can sub negative 11 over 4 into the equation to have a over 0 minus 2 is negative 2. Negative 2 squared is 4. And then minus 3. Okay, when I see this equation here, well, I can solve it, but I will feel like the denominator 4 is very annoying. Okay, that's my first feeling when I solve this. So I want to get rid of denominator, like when I solve equations. So I'll times 4 on both sides of the equation first. It's just make it easy for me to solve. And don't forget to times 4 with the 3 as well. So times 4 on both sides of the equation. So A is just 1. So can you see the question? The question is asking you find the value of A, H, and K, not really ask you to write the equation. So you need to say A is 1, H is 2, and K is -3. You need to state the value. You need to answer what is asking. When you just write the equation out, it doesn't mean like you answer the question. Okay, so you need to explicitly say A is what, H is what, and K is what. Same as the previous page, okay, I have stated A is 4 and K is 5 here. So it's ask you the value of A and K. So you need to state the value in the end. Okay, here is the end of chapter 4. Okay, here is the end of chapter 4. And I need to talk about more today about piecewise function. I think it's a good connection between chapter 4, finish chapter 4, and come back to chapter 5 at this point. Yes?
For the test, are we only being tested on
4 and 5, everything. Everything in this booklet. Yeah, 4 and 5.
So like, what about 5A?
Yeah, all will be tested. Yeah, like, but A to C, can you see like A to C is more like what's the domain, what's the range, what is a one-to-one function? It's all definitions. So we have go through all of these definitions in the original, like the chapter 4 as well. So we talk about the domain of the graph, how to use function notation to write the equation, how to use set notation to say the domain and the range. So that's just kind of like definitions here. Okay, let's have a look at chapter 5. It's not really something very new to you. It's just like, you know, like we can use one equation to represent like one graph. Like normally the domain will be R from that side to that side. But for some function, I want to represent something, but I can't represent by one rule. I need to give many rules to discuss that. So this is called a piecewise function, or it can called a hybrid function here. Okay, it can be a piecewise function or called a hybrid function. So which means from negative infinity to positive infinity, you don't use one rule to represent the graph. Well, you use more than one rules, like 2 or more rules to give this graph. We have this graph here. This graph follows 3 different rules, okay? That follow one rule. Well, if I can see, that will be 1, 2, 3, 4, 5. Like that might be y equals to 5. Okay, that might be a rule y equals to 5. And a domain only, well, if I say that's -1, -2, -3, -4, and -5. The domain for this y equals to 5 only be true when x equals to -5 to -3. Only true for that period. And then this might be a quadratic or a circle, part of the circle. Can't tell, but like I guess. I say that would be a quadratic, but the domain only works from, that's 3/2. So only works from -3 to 3/2. And then keep going. I have a linear function here. Also, I can find the gradient. I can find the y-intercept, and it only works from 1, 2, 3, 4, 5. That's only works from 3/2 to 5. So like different domain give you different part of the graph. Okay, different domain follow different rules. And we can also see here how many functions you can see here. 2 or 3? 3. There's a point here. That's one function as well. Even though there's only one point, use that function y equals to 6, but it's still like one function. So that's a quadratic and a horizontal line and the linear here, but the horizontal line only be true for 1 point. Also, another thing is, this is called a function. Okay, highlight that. That's called a function, a piecewise function. Okay, what is a function? Back to what we learned at the beginning. What is a function? Let's say it again. For for each x value. So there will be a unique y value for each individual x. Okay, so there will be only one y value for each individual x. So therefore, the domain for each function will not overlap. Okay, so I will say this quadratic can work from negative infinity to 2. And then the next function work from 1 to 3, like you overlap between 1 to 2, right? It's not working because each x can only got one y value for a function. So if you overlap the domain, which means the graph will overlap as well for that period of domain, you will have more than one y values. So therefore, you can see if I draw a dot line here, let's say that's when x equals to 2. When x equals to 2, can you see the quadratic graph? The domain doesn't include 2 because it's an open circle there. And the domain for the linear doesn't include 2 either because it's an open circle. So the only function include x equals to 2 is y equals to 6. So each x can only be included only once in this piecewise function. So if it's already included in the middle one, you can't include it in the left or the right function anymore. So only include it once. So same reason, when you substitute things, you only sub into one function, not sub into all the functions. So let's look at one example. This is a good example here. So this is a piecewise function, and the domain is x less than -3, x in between -3 and 3 inclusive, and x greater than 3. So we follow 3 different functions. We have a linear, and a hyperbola. My question is, okay, so see the fx. We already use function notation. Which means this is a function. Okay, this is a function. We can only use fx when it is a function. Before we start sketching, tell me what's f -4, what's f -3, what's f f0, and what's f5 equals to. Okay, just evaluate that for me. So when x equals to -4, what y equals to? When x equals to -3, what y equals to? When x equals to 0, what y equals to? And when x equals to 5, what y equals to? Just want you to simply to do the substitution and give me the y values. You need to think about the proper domain. Okay, so for -4, which part of domain it belongs to, and then therefore which function I should substitute in. Okay, what f -4 equals to? -1, because x less than -3, -4 is less than -3. So I will sub into this function here. So that will give me -4 plus 3, and that's -1. What's f -3 equals to? -3, it will be just this x here, -3. What's f0? Okay, f0 is in the middle of this domain. So it's follow y equals x as well, so it's 0. What's f5? 1/2. So 5 is in this domain, so it is 1 over 2. So 5 minus 3, 1 over 5 minus 3. All right, so we have those points. We can just label those points on the graph first. Okay, we have 0, 0, negative 3, negative 3, 3, 0, 0, 5 and a half, negative 4 and negative 1. I just randomly select some point, okay? It's not really on purpose. I don't know what that means, but like that's what I can have. Okay, my graph must pass through those points. And then let's have a look. Where is the separation line? Okay, we separate those graphs at negative 3, at 3. Okay, so from 3, negative 3 left hand side, that's one part of the graph. Negative 3 to 3 is one part, and then 3 to infinity is another part. So I will first draw some lines. Okay. So that's okay. We have 3 different graphs. We'll sketch the left hand side one first. Okay, the one to the left hand side to negative 3. So to the left hand side of negative 3, we have x plus 3. Okay, the last point this function will get is about negative 3. It's not really negative 3. Is, well, some number a little bit less than negative 3. But negative 3 is called the endpoint, even though we can't take it. It's the open endpoint. Okay, so that's the thing, the last value I can really see, but I can't take it. So I will sub negative 3. Endpoint is always important. Endpoint will be subbed into both equations, but one of them needs to be open circle. So I can't take negative 3, but I need to find endpoints. So sub negative 3 into the first function, I have 0. So I will have negative 3, 0 as an open circle. Okay, open circle. So negative 3, comma 0. Also, you know the graph can't go that way, can only go this way because you want the left hand side of the graph. So also remember we have find negative 4 and negative 1. We have find that point already, so we have labeled that on the graph. So that's one point. So also we know that's a linear. We can just connect that. We can just connect that. See that? That's the graph. Okay, that's the graph. Left hand side, I can't keep going with the right hand side. I can't keep going up because the points stop at negative 3. So negative infinity to negative 3. Yes?
How we found negative 4, negative 5? So when you draw a graph, you always have
What kind of graph is that? How many points you need on it? Yeah. But you can't have the y-intercept. You can see y-intercept must be on this side. But I can't find. If I can find y-intercept, I will find y-intercept instead of that point. But I want to draw a linear, I need 2 points. So I just randomly find one. If I haven't find negative 4 before, I will just sub maybe negative 5 to find another point and then connect it. It will be the same. Okay, it will be the same. So the next thing is y equals to x. Okay, fx, we just change that to y. So y equals to x. You know that's a linear path through the origin. Okay, no, that's a linear path through the origin. But also we have 2 endpoints. Okay, we have 2 endpoints. Negative 3 and 3. Negative 3 and 3. So when I put negative 3, I will have negative 3. That's already this point here. Negative 3 and negative 3. And also that's a closed circle. Okay, that's a just closed dot because I can actually take that point. Also, I will have 3 and 3. That's the other endpoints as well. Also, I can take that as well. So that's a linear as well. So I will connect those 3 points here to draw the linear. Okay, just remind you that, can you see when x equals to -3, on the left hand side function got a different y value, even though that's an open circle, but it's still a different value compared to the second function when you sub x equals to -3. But in some case, when you sub -3 in first function and second function, that will be the same. Okay, they share the same y value. One is open circle, one is closed circle. Open circle over closed circle, if they're the same point, that just become a closed circle. You don't need to show open circle anymore. Say if that point is the open circle is -3 as well, we just overlap with the closed circle here. So closed circle over open circle, that is just a normal closed circle. So the two graphs will connect it together. This is why you can see there's a jump, like the two separate graphs. So if you have the same y value, then that will just be a normal closed circle here. But it needs to show that point. You still need to label that point. It's a key point as well. All right, so let's have a look for the last one. Yes?
You have to like mark out the jumps.
No, you don't need to. This black line is just for you to first introduce, like you need to see that's 3 sessions. Yeah, you don't really need to draw that. Because when you label the coordinates, I know that on the vertical line. -3, 0, -3, -3. They're on the same line. Okay, the last one is hyperbola graph. What are the two asymptotes actually for this graph? If I can see that's hyperbola graph, but what's the asymptotes? X equals to 3 and y equals to 0. Can you see that's why the domain not including 3? Because you can't take 3 anyway. It must be like R except 3. So I will get rid of this black line, but instead I will draw the asymptotes. That's x equals to 3. And then I will do half of this as well. I will say that's y equals to 0. Why I draw half? Because I don't have hyperbola graph on the left hand side. My hyperbola only exists after this black line and onwards to the right. So I will just draw half of the asymptotes here. So, well, I have a point already. That's 5.5. Well, if I sub 4 in, I'll have 4.1 as well. 3.3 is nothing to do with this graph, okay? You don't need to care about the 3.3, like nothing to do with this hyperbola graph. So 4.1, so I just need 2 points to look at the scale. Okay, this graph needs to be reasonably close to the asymptotes and parallel to the asymptotes. And the asymptotes needs to be longer than the actual graph. Okay, the asymptotes needs to be longer than the actual graph. So I will label the 3.3 on the other side. It's quite messy on this side. That looks better. Also, like, you know, you will lose mark in the VC exam if you sketch like graphs like you can't sketch it and then you're trying to do it a lot of times like this, some graph like that. This, they call that as like hairy graph. When they give me the examiner report, they said no, it's not a smooth graph. A graph needs to be supposed to be smooth. So if you really sketch something like this, they will take mark off. Okay, that's half mark off because the graph is not smooth enough. Also, well, when you draw like asymptotes and then you say, that's my graph, they not treat this as right. Okay, they say it's wrong. They say it's wrong. when I go that session and then the examiner talk about how to mark the paper, I was quite surprised actually. Like I think I like to see like pretty and neat graph. I'm quite against those graphs, but I don't really think they will take marks off. But they told us like they really take marks off when they draw those kind of graphs. So really be careful with that. I was quite surprised actually. I think this VCA is more testing to know what is it, can you do it, but they actually pick on those small tiny things as well, so just be careful. Okay, I can get rid of this black line here already, so that will be the hybrid function. Okay, that will be the hybrid function. All right, any questions regarding to this one? Any questions? Okay, if you don't have any question, please go to the next page. Okay, what I'll tell you here is, this is a quadratic. Well, this is a linear, you can see it, and this is the truncus. I want you to find the rule for this hybrid function. Okay, I want you to find the rule for this hybrid function. So you need to state the rule and you need to state the domain for appropriate part as well. If you can't read that, I'll tell you this is an open circle, 2, 0, and then here is a point 4, 0, and here is a point 3, -2, which is the turning point. And then this is a closed circle with 2 and 5. This is -2 and 5 with a closed circle on both ends. And then this is a truncus graph. This equation is x equals to -2. And this horizontal is y equals to 2. Okay, so that's the information. And also there's a point -3, 0 as well. And also that's a truncus. Okay, that's part of the truncus, not part of the hyperbola. I will tell you. I'm telling you the information, additional information. Which one? Oh, yeah, that's 3. That's 3. That's not 5. Yes. That's 3. Okay, so give your 7 minutes. Okay, give you 7 minutes to work on the rules and the proper domain as well. It's not going to take you that long if you know what you're doing. Okay, so the easiest one will be the middle one, which is a horizontal line, and we have y equals to 3 for that for sure. And then I will work on the easy one. Maybe the quadratic will be easier. My question is which form do you select to solve for it? Like there are 3 forms: general form, turning point form, and x-intercepts form. Okay, so half turning point, half x-intercept. That's all right. But I would say if you have turning point, I would prefer turning point form. Like turning point form is more useful compared to the x-intercept form. Well, it will be the same level of difficulty even you solve by turning point form and x-intercept form. But when you get the final form, the turning point form can be more helpful compared to the x-intercept one. So I'll prefer to use the turning point form here. Therefore, we will have y equals to ax minus 3 squared minus 2. And then we can select any points to substitute. I can select the 2, 0, even though it's not really part of the domain. But like it's still, if you have the full graph, that will still be on the graph as well. We can select the full 0. So I can say 0 equals to a times 1 minus 2. So a equals to 2. Therefore, we have a rule y equals to 2x minus 3 squared minus 2. Well, when you use x-intercept form, you will have a different like equation, but it will be the same. It will be equivalent. Okay, last one for a truncus. Okay, for a truncus. For this truncus, we have x asymptotes at -2 and y asymptotes at 2. So what we'll have is y equals to a over x plus 2 squared plus 2. Okay, for the basic equation, what we have like a over x minus h squared plus k. Okay, so because I need the intercept at -2, so therefore the denominator will be x plus 2. When we solve it equals to 0, then we have x equals to -2 as the vertical asymptotes. And then the horizontal one is just the k value, which is 2. No problem with that. No, I'm telling you that's a truncus. Like I give extra information at the beginning. I said very beginning that's a truncus. I'm telling you that's a truncus. Well, otherwise I can't say it's a hyperbola or like a truncus. Okay, and then I need to substitute the point -3, 0 into the equation. 0 equals to a over, well, you put -3 in. That will be -3 plus 2, which is -1 squared, still 1, and then plus 2. So a equals to -2. So y equals to -2 x plus 2 squared plus 2. If you use the hyperbola function, your a value will be 2 instead of -2. Well, if you use hyperbola. But like this, because like the question should tell you whether it's a truncus or a hyperbola. So if I'm telling you that's a truncus, you need to use that equation. And now I need to put everything together to write the function notation. I will say fx is a hybrid function here. So -2 over x plus 2 squared plus 2. Well, I'll use an interval notation. X belongs to -infinity to -2 exclusive. Doesn't really matter, but like it will ask you to do, for example, interval, or like if it doesn't say, you can do anyway, but when they say you must use interval, use interval. You can't write x equals, like it's a set. You can't use equal. Equal is not for a set. Yeah. Well, if I'm not like saying anything, you can do that. But when the question says you need to use the interval, then you need to use interval. For this question, it's fine because it doesn't really say. But I think if you learn interval notation already, in the end, in the VC, you will use interval notation anyway. You're not going to use like less than or greater to. They're not asking you to do that. So you need to learn how to do this. Okay. Also, I think interval notation is a more clear representation. You can never get the direction wrong. Like when you say x greater than 3, some students just can't distinguish between the greater and less than. And sometimes it's too nervous and then just always write into the wrong direction. But that one you can see is from the smallest number to -2. Yes?
When you're writing them down, is there a specific order you have to put in?
I'll prefer from smaller to larger, or larger to smaller, but not middle first, and then larger, and then smaller. Okay. And the next function is y equals to 3. So 3, x belongs to -2 to 2, inclusive both ends. And the last one is 2x minus 3 squared minus 2. That's the quadratic. where x belongs to exclusive to infinity. The value can only be included once in the whole hybrid function. So we already take -2 and 2 in the middle one, so we can't take it in the top and bottom one. So that's the full solution to this question. Okay, so we finished this exercise now. You can't. That's why I'm telling you that's a truncus, not like a hyperbola. But otherwise, if just give you the graph, you can't see it. Like if only half of it, you can't see it because they look exactly the same. It's only the dilation is a little bit different, like more close to the asymptotes or far away from the asymptotes. But like you can't tell. The question will tell you what kind of function is that. Any other questions? Okay, if no, we have done all chapter 4 and almost everything in chapter 5. We have 2 more exercises. Tomorrow is inverse function and next lesson will be just a modeling.